On Earth, firing a gun is a common occurrence. But in the vastness of space, what happens when a gun is fired? When we consider firing a gun in space, everything becomes extraordinary. In the vacuum of space, how does a bullet behave? Will it fly indefinitely? Or does it have an end? Let's begin by considering the physical environment of space. Space is a near-perfect vacuum. There is no air resistance and no gravity. In such an environment, Newton's first law of motion, the law of inertia, takes precedence. This means that an object without external forces remains stationary or moves in a straight line at a constant speed. When an astronaut fires a gun in space, the bullet is propelled by the explosive force within the firearm and ejected from the barrel. Due to the absence of air resistance, the bullet does not slow down as it does on Earth. It continues to travel at nearly its initial velocity, unless it encounters another object or a gravitational field. The universe contains countless stars, planets, and black holes. Their gravitational pull can affect the bullet's trajectory. If the bullet comes close enough to a planet or other celestial bodies, it may be captured by their gravity, enter orbit, or fall directly onto the star's surface. However, if the bullet moves far from any star, there won't be enough gravity to alter its course. Then, it will continue to travel through space. Here's an interesting question. Can a bullet reach the edge of the universe? We must first determine where the edge is. In fact, the universe is expanding. It doesn't have a fixed boundary. The bullet's speed cannot keep up with the universe's expansion. So, in theory, it will never reach the edge. But this is not the end of the bullet's journey. Over time, the harsh environment of the universe will affect the bullet. It may be damaged by cosmic radiation and gradually deteriorate or collide with other matter, changing its path. Space is not completely empty. Cosmic dust, micrometeoroids, or other microscopic particles will eventually collide with the bullet, even if these collisions are minor. Over time, they will gradually alter the bullet's speed and direction, and the extreme temperature changes in space will also affect the bullet. It could change its internal structure. What's also interesting is that firing a gun in space creates a reaction force. According to Newton's third law, every action has an equal and opposite reaction. In space, the recoil from firing the gun directly affects the shooter. Due to the lack of an environment to counteract this force, such as ground or air resistance, the shooter may be pushed backward. If the shooter isn't anchored, this reaction force could cause the shooter to lose control. Floating in space. This is especially dangerous during spacewalks or activities outside the space station. Another danger is that the behavior of firearms in space is unpredictable. Extreme temperatures, microgravity, and a vacuum environment can cause weapon malfunctions or even explosions. This risk is something we cannot afford. If the bullet or firearm parts break apart in space, they will travel at extremely high speeds, potentially becoming dangerous space debris. Even small pieces can damage spacecraft, satellites, or spacewalking astronauts, causing serious damage. It's important to know that, in environments like the International Space Station, carrying weapons is strictly prohibited. These rules are in place to protect astronauts. Violating these rules can have unforeseen consequences. Finally, don't forget the psychological impact. Space is already an extremely stressful environment. Even though gunshots wouldn't be audible, this potential danger increases the stress on astronauts, affecting their task performance. Therefore, although theoretically, firing a gun in space is possible, due to the potential risks and complexities, astronauts will not perform such an operation during a mission. And there are more important tasks to complete. So, if you were given the chance to fire a gun in space, would you want to try it?